lesson 10.7, which we're moving into something called area probability. So basically we did an entire section over specifically probability. So now we're going to be taking the area and tying it into a probability. So what is the probability of actually hitting a certain spot on a target or a certain something on a board or something like that? So let's go ahead and jump into that. So the key points, it says calculating the likelihood of an event occurring with the formulas without conducting an experiment. So we're actually going to be doing this thinking this is theoretical, obviously, without conducting the experiment. So just like regular probability, the probability of an event happening, if we're dealing with area, obviously remember, you always want to put what you want to happen on top. So you want to put the area of what you want to hit on top over the total amount of area of your shape. So again, what you want on top favored, so I'm gonna go and just write that in there so you guys can have that in your notes. So you want favored, what you want over the total is what's gonna go on bottom, okay? So let's take this concept and let's tie it into our examples down here. All right, so on example number 1, it says if a dart is thrown at random and the diameter of the blue is 10 inches, the diameter of the yellow is 6 inches, and the diameter of the red is 2 inches. We need to find the total probability. So right now we need to figure out what's the probability of me hitting the red dot. So remember, we want to find what I want on top and the total on the bottom. So what I want on top is the red. So that means I need to find the area of the red. Well, I know the diameter of the red is 2 inches. So that means the radius of that's going to be 1. So to find the red, I'm going to do pi times 1 squared, which 1 squared is just going to be 1. So it's just going to be pi on top, correct? Okay, that's the area of the red. And now I need to find the area of the whole thing. So the area of the whole thing is going to be the blue part, right? So the diameter of the blue is 5, or diameter of the blue is 10. So I'm going to take half of that, which is going to give me 5. So I'm going to do pi times 5 squared, okay? So if I do, in my calculator, I'm gonna do control divide, I'm gonna do the pi symbol, and I'm gonna end up doing 5 squared times pi, and whenever I divide that out, that's gonna end up giving me a 0.04, which if I move that 2 decimal places over is going to end up giving me a 4% chance of that happening. So theoretically, if I throw something at this board and I hit somewhere on the target, there's a 4% chance that I'm going to hit the red, very low chance, okay? Now let's figure out for yellow. So right now I'm going to do the same concept. So, but what you notice here is the yellow here is being taken by the red here. So I'm actually going to have to subtract out the red in order for me to get the yellow here, okay? So let's go and look at this. So I know the diameter of the yellow is 6 here. So half of that's 3. So I'm going to do pi times 3 squared. And then I actually have to subtract out the red. Well, the area of the red was pi, right? So I'm just going to multiply that by pi. And then I'm going to divide all that by the total area, which the total area was the blue, and I already have that here, which was pi times 5 squared. And so now literally I just have to end up multiplying all that out. So control divide, and I'm going to end up doing pi times 3 squared minus pi, and I'm going to multiply that by 5 squared times pi. And when I click enter, that's going to end up giving me a 0.32 chance, which 2 decimal places over is going to end up giving me about a 32% chance of that happening. So again, dealing with area, you're doing what you want on top, and you're going to do the total on bottom. That's going to end up giving you what you want, okay? Let's jump over to example number 2. All right, so on example number 2, it says, what is the probability that a ball thrown at the target will hit the shaded region? So I want the shaded region, okay? So in order for me to get that shaded region, I have to take the total and I have to cut out that circle. That's gonna end up giving me my shaded region. So right now I have a rectangle. So the area of a rectangle is base times height. So I'm gonna do 8 times 6. And then I'm gonna have to end up subtracting out the area of the circle. Well, if you look, all the way across from here to here is 6. So half of that is gonna end up giving me 3. So the area of my circle is gonna be pi times 3 squared. and then I'm going to end up dividing all of that by the total area, which is going to end up being 8 times 6. It's going to end up being my total area of the rectangle. So control divide. I'm going to do 8 times 6 in parentheses, and then I'm going to be subtracting out the area of my circle, which is pi 3 squared, and I'm going to divide all that by 8 times 6, which is in return going to give me 0.41. So all of this is going to end up turning into 0.41, which if I move that 2 decimal places over will give me about a 41% chance. So kind of higher than the other ones that we were doing over here. So there's a 41% chance that if I throw something at that target, it's going to hit the shaded region. Okay, let's jump to example number 3. Okay, so on example number 3, it says, what is the probability of hitting one of the triangle targets? So remember, I want to hit the triangles. So now with that being said, I have 2 triangles and they're actually going to end up being congruent. So that means I have to do 2 times the area of a triangle. So I'm going to do 2 times 1/2. The base of my triangle is 3.5. The height of my triangle is 5. So remember, what I want is going to go on top. So the area of my triangles is going to go on top. Okay? Now on bottom is going to be the total area, which is going to be a rectangle. So base times height. So I'm going to do 13 times 13. So I'm going to end up doing 2 times 0.5 times 3.5 times 5, all being divided by 13 times 13, which will end up giving me a 0.103 chance. 2 decimal places over will give me about a 10.3% chance. So if I was to throw something randomly at that target, there is about a 10.3% chance you have to hit that target or those triangles. Okay? All right, and lastly, look at the last example here. It says, what is the probability of the spinner landing on green? So that means I need to take the total area, which is going to be the area of my circle. But if I look, I'm only given degrees here. So I can actually take the degrees and I can get my ratio just by looking at the degrees here. So right now, if you look, my degree of my, hold on. So the degree of my green is going to be 170. So the probability of hitting green is actually going to equal 170 over the total, which is 360. So the total circle is 360. So I want green, and then the total is going to be 360. So when I divide that out, that's going to end up giving me my percent. So 170 divided by 360 as a decimal is going to be 0.47. Which is going to be about a 47% chance, which is going to be a lot bigger there. And now, what is the probability of the spinner not landing on yellow? So if you look, 170 and 100 are not yellow, so that would be 270. So the probability of not yellow is going to equal 270 over 360. So I'm going to do 270 divided by 360 as a decimal, and that's going to end up giving me 0.75, which is about a 75% chance. You could do the same thing with the area of those sectors if you needed to, and then do the total over, or what you want over the total. That's all you need to make sure you understand when you're dealing with probability. So ladies and gentlemen, this is taking area and applying it to probability. If you have any questions, call me over. I can give you some help. Other than that, good luck on your skill check. Holler at me if you need any help.